Hi everyone, let's review Unit 2 Quadratics, the first third of the unit. This unit's split into three, and there will be three quizzes. So here's the first part, which relates to the first quiz. So here's the handout you'll need, and you can follow along by filling in all the blanks. So we're looking at quadratic relationships, and that's where you have y equals, and it's always going to have x squared. In fact, the squared tells you it's a quadratic. That's how you can tell by an equation if it's quadratic, if there's an x squared and no higher exponent on the x's than that. Okay? Quadratics will graph as what are called parabolas. So the shape of a quadratic is a parabola, and it kind of looks like a curve. So let's look over here. There's the x-axis, y-axis, and there's the standard quadratic of y equals x squared. And it comes from taking these 5x values, squaring them, because the y equals x squared, and finding out what the y values are. So minus 2 squared is 4. 1 squared is just 1. 0, 1 squared is 1, and 2 squared is 4. So if you take the time to graph these pairs, minus 2, 4, minus 1, 1, 0, 0, 1, 1, 2, 4, you'll end up with the basic quadratic of y equals x squared. And we're doing this because the quadratics we're going to use down the road, we're going to do applications, okay? We're going to look at making y be height, x will be time, and you'll have like a maximum height. So we'll do like maybe sports or missiles. They involve heights. We'll also look at x being time eventually, y being profit, and you can have like a maximum profit, so that says max for maximum, and this would have to do with like finance. So let's look at the properties of a quadratic, which we can also call a parabola or a curve. First off, there's the y-axis. We say y to the sky goes up, and then x goes across. And there's your positive x values, positive y values, negative x values, negative y values. Okay, let's take a look at this first quadratic. Notice that this quadratic is different than the original one, y equals x squared. This one's been transformed. It's in a different spot. It looks bigger, okay? So let's talk about his properties, and we'll try and generalize about all the properties of quadratics. Okay, so first off, this quadratic, these arrows means it continues up this way and keeps growing, and this way also goes up and keeps growing. Down here, we have what's called a vertex, and in this case, since this is the lowest point, it's a minimum. It's like a minimum value. And it actually turns out to be at x is 3, y is minus 1. Okay? We say that this quadratic opens up because it's opening and going upward. Okay? And there's really important points. Along the x-axis where it crosses, at those two coordinates here, that's 2, 0, and that's 4, 0. We have names for those. Those are zeros. Okay? Or roots. Another one too, you could actually call these x-intercepts because they're intercepting the x-axis. All right? This faint line here, where basically the minimum occurs, is what we call an optimal value. And that optimal value line behind my pencil is happening always at, well, y is minus 1. So right along there we say the optimal value is y equals minus 1. Okay? And then if you split this quadratic in half, it creates like a mirror line. We call it the axis of symmetry. And it's this dashed line that we draw. And it occurs, if you look where my pencil is, at x equals 3. So we have an equation for it. X equals 3. Okay, another parabola, which is this time it's been reflected. It's like you've taken this one and you've flipped it over so it's been reflected. So something notice is it opens down and it's been reflected. Like it's reflected relative to always comparing to this original y equals x squared. Compare how he looks to this one, it's been reflected. Okay, next up, you have a vertex, but it's not a minimum. This vertex here, that top point, is a maximum. And it seems to be happening at minus 1, 2, 3, 4. So at minus 4 and up 1, 1. Okay? So he's got a maximum. He's also got these 2 points where the parabola crosses the x-axis. So there's the x-axis behind my pencil. And it's crossing here and here. Those are, again, zeros or roots. Okay? So the zeros or roots, same name. You know, or x, and I'll write int, it means x-intercepts. There's 3 names for the same thing. There's an x-intercept at minus 5, comma 0, and there's another one at minus 3, comma 0. Okay? That defines the basic properties of a quadratic. So these quadratics, which we like to look at as graphs, which we call parabolas, they can be transformed. They can change. And they change relative to what y equals x squared looks like. Here's y equals x squared. So we talked about how there's an a value, an h value, and a k value. And they have this effect. Let's see what a stretch would do. So here in blue, if I stretch a different version of this graph, stretched, it would essentially pull it up sooner. So that's a stretch. Okay? It comes up sooner. If I compress, well, compression, it sort of flattens it. So it creates this flattened quadratic. All right? And I know it's hard to see, but here it says reflect, like a mirror's reflection. So there's a hole punch through it. Okay, so that's reflect. So if you take the original graph, the one in pencil behind my finger, and you reflect it down, it would look like a mirror image along here. Okay, and that's reflect. It's a little hard to see, so I'm going to kind of use dashed pencil here. Okay, that one's been reflected. The other options is relative to this original graph in pencil, it could move left or right. So I'm going to move this original pencil graph right, and you get the effect of the pencil graph behind my finger here. It could move over anywhere. It could end up starting over here, or even beyond the graph, you extend it over here. Well, I'm going to start one here. It's going to have this same shape, and it's been moved to the right. All right? And then you can also move it left, which would just send it over here. That's the h value. And the last one, okay, I'm going to use this blue again here, so just be aware. I'm going to move this one down. Okay, so here's the original graph, and I'm going to move it down. So this original graph in pencil sort of starts down here. And it started lower, so his minimum is lower. And that's due to the k value. Okay? So those are all the transformations. You can even have cases, and we're going to see some, where you end up changing multiple things. So a, h, and k, all these values have an effect. Okay? For instance, earlier in the lesson, have a look at this graph. Well, this guy looks a little wider than the original one, so he's probably been compressed. You can tell he's not starting at the origin. He's been moved to the right and down. So this guy's been compressed, moved to the right and down. He's had many changes, which we could all capture with a, h, and k. Okay, so let's find a for y equals ax squared if you're given the point 4 comma minus 8 is on the equation's graph. 4 minus 8 is an xy point being given to you, and your first step is to realize x equals 4, y equals minus 8. And we don't know what a is, because in this equation, those are the only 3 variables. So your second step, use the equation, and you're going to substitute. You're going to substitute. You see how it says y? Well, we know y is minus 8. So let's put minus 8 there. We don't know a, and we're told x, which is being multiplied by a, is 4, and I have to square it. Okay? So that becomes minus 8 equals you have to square this, so that's a times, well, 16. 4 squared is 16. Okay, continuing over here, minus 8 equals, well, 16a's, because a times 16 is the same thing as 16a. And now I want to undo 16 times a, so I divide by 16. Okay, and this cancels. You'd have a remaining minus 8 over 16, which we know is a fraction that's less than 1. Like 8 divided by 16 would be less than 1, and then there's a negative. Okay, so actually that's exactly negative 0.5. And when a, if you skip looking at the negative, if you just look at the number for a, 0.5, if that's between 0 and 1, you know it's been compressed. Because the question asks you to state the transformations usually. It didn't in this one, but I'm going to do it anyways. So a, if it's between 0 and 1, ignore the sign, it's compressed. Okay? The negative sign now, that tells you it's been reflected. So it's like this new quadratic relative to the original that's been flipped over and flattened or compressed. So since we're learning that these quadratics can be transformed, we've got this overall equation that explains all the different players, so a, h, and k. They explain how those players are involved in changing or transforming the basic graph of y equals x squared. So let's look at this a. If there's an a in front of the x, okay, a value, and this means if like a is greater than 1, you just look at the number. For instance, if it's like 2, 6, minus 10. Remember, you just look at the number. So 2, 6, and minus 10, I'm looking at the number 2, 6, or 10. If that's greater than 1, then you know it's been stretched. Okay, so it gets skinnier. Okay? Whereas if a is between 0 and 1, numbers like 0.1, 0.5, 0.95, minus 0.2, minus 3, you know it's going to be compressed. So it takes that original graph and like flattens it out. Okay? Also, the reflection, it depends if a has a negative. So it has this negative sign. If you see a negative at the start of your equation, you know it's been flipped. So it'll end up this way. It'll flip over. Okay? The h value, you have to see it inside brackets. If you don't see brackets, there's no h value. Okay? The default for h is usually 0, but if there's some value, it could move it left or right. Okay? If you see a 3 here, like for instance you see minus 3, it says minus 3, that means it's actually moved right because it lies to you. Everyone thinks minus 3 is like left on a graph, but it's lying to you. It moves right 3. Okay? The last value is k. So at the end of your equation, if it's adding a value, that'll cause the graph to move up or down. And k can be positive for up, and if k is a negative number, it'll move it down that amount. So let's take a look at some examples. Okay, so we kind of have our rules. Now we'll do an example. Describe the graph of each parabola relative to, well, always relative to y equals x squared. Let's describe this guy. This guy has a 2 in front of x squared, and there's no brackets, and there's nothing being added at the end, so that's got to be my a value. And it's definitely greater than 1, so it's a stretch. So this has been stretched by 2. That's it. Okay? The basic vertex, the original graph's basic vertex, if you remember, where does the basic graph always start? Here it is in pencil. It always starts at 0, 0. So if there's been no change, you know it starts at 0, 0. So the second thing for part A, state the vertex. His vertex would be 0, 0. Let's write that out. Okay? Next it asks, is this a maximum or a minimum? Well, it only becomes a maximum if it gets reflected, if it opens down like this. And for it to open down, all the ones that open down need a negative sign in front of it. So let's just take a peek. Is there a negative sign here? No. So it won't open down. Is there a negative sign here? No. What about part C? Yes, this one will open down, as will this one because of the negative sign. And these two won't. So that's how you know if it's a maximum. Otherwise, it just looks like the standard way, which we call a minimum. Okay? Let's try question D here. So D, let's read through everything. We see at the front there's a negative sign, and we know that represents the A value. But there's no number. Well, it actually means minus 1. Okay? So if A is greater than 1, well, it would stretch. Well, it isn't. It's 1. If A is between 0 and 1, well, it's not between it. It is 1. So you would say here that there's no stretch. The negative sign, though, if A is negative, well, yeah, A is negative. So here we would say that this one reflects. Then we notice there's brackets, okay? And we can see that there's a 9 there, but it lies to us. It's actually moving to the right 9. And then outside here, you get your K value, and it would be moving up 6. That's how you would describe everything. Also, we remember from earlier, with the negative sign here, this one will open this way. It'll be reflected. So you can see it opens down, and it would have this maximum value. So you can try these. Check in with me, check in with some of your classmates, and best of luck.